Hi class, today's lesson is lesson 8-5. It's about triangles. Our purpose for today is to classify triangles and solve problems involving the angles and sides of triangles. Let's go ahead and write down our first three vocabulary terms. And these all deal with classifying triangles by angle. The first term is an acute triangle. An acute triangle is in a triangle where all angles are acute. They are less than 90 degrees. Here we have an acute triangle. We have 55 degree, 50 degree, and 75 degree angles. An obtuse triangle is our second type of classification by angle. An obtuse triangle has one angle that is obtuse. And as you can see, the obtuse angle that we have here is the 135 degree angle. It is greater than 90, but less than 180 degrees. Finally, a triangle that you're very familiar with, it's a right triangle. A right triangle has exactly one angle that is 90 degrees. Oh, notice that I forgot to insert the letter E for one. It's not on angle is 90 degrees, but one angle. Now, what we're going to take a look at are the angles, the angles of any triangle. Now, what I'm going to write down here is a truth about angles. The sum of the angles of all triangles equals 180 degrees. If you add 55 plus 75 plus 50, you get 180 degrees. If you add 25 plus 135 plus 20, you get 180 degrees. If you add 50 plus 40 plus 50 plus this 90 degree angle, you'll get 180 degrees. Let me show you physically how that looks. I'm going to go ahead and simulate ripping these angles off of this triangle. And I'm simply going to rotate them so that they fit like puzzle pieces. This is going to be my centerpiece. Rotate this just slightly this way. Boom, it fits right there. I can rotate it just a little bit more. There we go. Fits right up against there. So I've summed up these two angles, and it looks like it's going to be an obtuse angle, obviously, here. Now I've got to rotate my last angle. And get it a little closer. Now check it out. The sum of these three angles gives me a straight angle, 180 degrees. That proves that the sum of any triangle's angles will equal 180 degrees. Now we have another classification of triangles, and this time it's by sides. A scalene triangle is our first triangle that we classify by sides, and in a scalene triangle there are no congruent sides. All the sides of this triangle are of different length. Next we have the isosceles triangle, where it has exactly two congruent sides, noted by these tick marks here. Exactly two congruent sides. A third side is not similar in length to the other two. And finally we have the equilateral triangle, and by looking at these tick marks you can understand that all those sides are congruent. So the scalene, no congruent sides; isosceles, exactly two congruent sides; and equilateral, all three sides are congruent. First example, this is a half sandwich. It's shaped like a triangle. Measure of angle A is 90 degrees. So I'm going to put this mark here. And the measure of angle B is 30 degrees. Classify the triangle. Well, with this angle right here in and of itself, this 90 degree angle, it becomes a right triangle. Example 2. We're asked to find the angle measurements of two angles. Let's look at BDE first. So we're asked to look for BDE. That's this right here, this angle right here. In order to find BDE, I need to be able to find another angle. In fact, I can see that BDE is the same or congruent to this angle. Why? Because they're vertical angles. Remember that? They're vertical angles, and vertical angles are congruent. So what is this measurement? Well, I know this forms a triangle, so this 30 degrees plus the 35 plus this unknown angle, and we'll call it just an angle A, equals 180 degrees. Now I just go ahead and solve for A. I have 65 plus A equals 180. Subtract 65 from both sides. 65's drop out. A equals 115 degrees. So this is 115 degrees. Therefore, angle BDE is also 115 degrees. Next, we're going to figure out angle ADB. Angle ADB is this angle right here. Now, we can use our work with the previous triangle work to get this particular angle, because I can see that this angle plus this angle equals 115 degrees, or 180 degrees. Why? Because this right here is supplementary. And we know that supplementary means two angles that, when added together, equal 180. So I'm going to add 115 plus second angle, we'll call it D, equals 180 degrees. Subtract 115 from both sides. 115's drop out, D drops down. You get a 5 here, and we get a 65 degrees. So this, in itself, BDE, or I'm sorry, angle ADB equals 65 degrees. Next, we're going to classify the triangle using the lengths. The perimeter of the triangle is 7 8/10 centimeters. We have 2 centimeters here, 3.8 centimeters here, and A here. So I know that the 2 centimeters plus the 3.8 plus the A gives me a perimeter of 7.8, or 7 8/10. Now I'm going to add these together. That's 5 8/10 plus A equals 7 8/10. I'm going to go ahead and subtract 5 8/10 from both sides in order to isolate the variable. 5.8 drop out, the A drops down, and I have 2 as the measurement. 2 centimeters is the measurement for this side. Well, exactly 2 sides are the same in length, in measure of length. Therefore, this becomes an isosceles triangle. Now this is your problem. It says, what's the measure of angle QTR? QTR. QTR is this angle right here. What is the measurement of that angle? You're going to have to use your understanding of the measures of this triangle in relation to this angle in order to figure that out. All right, good luck. We'll see you in class.